My name is Uwe Koppe, and today my presentation is about migration from classical CAN to CAN-FD. Okay, at this point, you might ask yourself, what's it about? It's quite easy, switching from classical CAN to CAN-FD, because what are the changes? What are the differences? We have an additional bitrate switch, we have an FDF bit, we have an additional bitrate setting for the data phase. Okay, that's one side of the metal. But every metal has also a dark side, and today I show you something about the dark side. This is a picture from the so-called anonymous CAN programmers meeting. These are guys who are addicted to CAN for years. You can see actually these people, when you look into the symptoms, it is, and you ask them, what is your problem? They say, well, my hands are moving like this, even in the night. And they are shivering, they're having cold sweat, and things like that. And there are groups, self-aid groups, even in your town, who can help you. And today, I'm here and I can say, well, greetings from my group from Cologne, from the Anonymous CAN Programmers Group Cologne. And I'm proud to say, I am writing software for CAN bus application. But what is causing these symptoms, these nightmares, this shivering in your hands? And when we have a look, what is the reason for that? Then you see here some APIs for CAN that are existing. By the way, did I miss some logos of people sitting here? If so, my apologies. They couldn't fit all of on this slide. So when we have a look here, you will see logos of typically PC board manufacturers. You will see logos of manufacturers of CAN silicon. The one part, the board manufacturers, they have a long history. 20 years ago, they made their API, and they're maybe happy with that, and you are happy with that. But since some years, also all these manufacturers of CAN silicon are approaching and giving you megabytes of software for their IP. And maybe you stick to this. You say, oh, it's there, it's free. Nothing is free. I come to the point, what is free, a little bit later. So the point is, and that is the reason why I'm here today, we have CAN, and we are moving to CAN-FD. But we have enormous, vast of APIs which are out there in the world. And this is causing my symptoms. So now, when you go to the doctor and asking for help, the question is always, so what kind of medicine can he give you, and how can you overcome these symptoms? I give you an example of a tool to understand what it's all about. Who knows this tool? Please raise your hands. Okay, come on, don't be shy. I know that there are more people who know this tool. Raise your hands. Okay, thank you. Okay, second question, who likes this tool? You're a liar. Definitely. So what is the problem with this tool? If you're using this tool, you may have noticed that sometimes the test results are okay, and sometimes they are not okay. Sounds a bit strange. Yes, but the reason, one of the reasons for this, is the CAN driver. The name of this CAN driver is COTI, CAN Open Test Interface. It's a very old API from the good old days where people were thinking that remote frames would save the world, but it's still there. So what happened is that PC board manufacturers made a wrapper above their existing API. This is COTI. So in the end of the days, today we're faced with the problem that when you run a test with PC card interface A and running the same test with PC card interface B, you get different test results. Why? This shouldn't be there. If there would be the same API, the same functionality, we wouldn't have that problem. So actually, the solution is already there. The solution is that we have within the CAN automation, we have documents for requirements for CAN FD and their API. That is the 602 part 2 application layer. Sorry, I've got the wrong reference here on the slide. And the 603, the requirement for network time management. These are the two documents that I have to reference now. So now it's like, for me now to speak here, it's like Christmas. I'm presenting you my wish list for the next Christmas. From the point of a programmer, what I would like to have in an API. First of all, obviously, I want to have a CAN state, fin state automation, which means I need initialization, I need operation, I need buzz off, and I have to handle these things. The next thing is, what I would like to have is receive only. Because in some cases, I would like to do simply a bus sniffing, for example, to do an automatic bitrate detection. That is why I would like to have a receive only thing. The next thing is I would like to run a self-test, because I have some test cases that I would like automatically run before I start all the system. And we heard that already too in the last presentations. I would like to have something like low power. I want to switch the system off. And for all of these things, I would like to have unique API functions. The next thing, and this is for me personally the most important thing, is what I would like to have are message buffers. And I would like to have many of them. This is especially a wish to all these PC board manufacturers which only offer me APIs like open, close, read, and write. Meaning, or telling me by this API, okay, open the interface, get all the messages which are out there in the world, and do it on your own. And that is not my intention. It's already there. It's in the hardware. So we have the possibility that we have many buffers. We have the possibility that there are acceptance masks, which means I can filter messages in hardware. I don't want to deal around with that later on in software. I want to set it up once in advance, and then I want to write my software with that. So I want to have an API where I have lots of message buffers. And the CIA 601-2 describes these message buffers, which says we have possibly single buffers, we have the possibility to have FIFO queues, we have the possibility to have priority queues, and we would like to have this acceptance filtering. So that is, from the API, from the programmer side of view, it's one of the most important things that we should have. The next thing is timestamp. We already addressed this yesterday. And we came to the point and we said, okay, we would like to have a 64-bit timestamp. And when we are looking into the CIA 603, we will see there that it says, the resolution of that can be some be around 1 nanosecond to 1 microsecond. I'm asking why? Yesterday, somebody told us, I think it was from ESD, he told us something about, with this setup of the timestamp, I have a period of 7,000 years. I'm asking you, do you really need 7,000 years? I don't. Sorry, I don't, because I'm dead already there, and maybe all the mankind is dead in this time frame, so I don't need 7,000 years. With 1 nanosecond resolution, we can cover more than 500 years. And I would say, hey, guys, this is plenty enough time to cover. I don't need more. So I want some additional features on my wish list. What I want are some message markers. Message markers are important for me. Let's say when I want to transmit a message, I want to know exactly when was this message sent on the bus, because messages, if I've got multiple messages in buffers and they are sent out, I can't say through priority one, are they really sent out on the bus? So, and there are solutions for that. When we are looking into the Bosch IP, this is already there. And it's already a recommendation in the existence CIA documentation. The next thing that I would like to have is I would like to know something about the CAN error status. In what state is this CAN thing? I don't only want to know it is active or it's bus off. I would like to know things in between. And now we have these features. So I would like to know what is the current error state of this thing. Also, I would like to have event support, and I would like to request capabilities. When I'm talking about request capabilities, I'm thinking about what is the capability of the CAN transceiver. Is it 2 megabit as a maximum, or is it 5 megabit? I would like to know it. I don't want to look it up in the datasheet. These are my additional features on my wish list. And, of course, there are some software requirements. These software requirements, when you're selecting a CAN API, is documentation. It's the code compliance. The automotive guys here always think about MISRA-C. I'm already thinking about CERT-C. It's the question of the license. How is this API licensed? And last but not least, we're coming back to the costs. It's the TCO, the total cost of ownership. How much does all this stuff cost me? Because as I said, nothing in the world is for free. With one exception. There's sometimes, but only sometimes, you get a free beer. And you have the possibility to get this free beer next week on the Embedded World. So you're invited to our booth. There you get a free beer. And it's, as I said, it's really free. Yeah? We don't sell you something. So, and if you're just right now, because you're saying, oh, I take this chance, I take this opportunity for a free beer, and you're thinking, yes, I come to Nuremberg, stay here overnight. Yes, do this, because in the next week, Wednesday, on the 15th, there is the Canon Automation General Assembly in the evening, 6:30 at the Canon Automation office, as far as I know. So if you're a Canon Automation member, that's your possibility to give your vote. As you remember, you already paid for that. As I said, nothing is for free, only the beer. So you are invited to the Canon Automation General Assembly. So this is the end of the advertisement block. So calm down, I'm not finished. So now we have a look at different CAN APIs. And I've selected 5 for the criteria I presented to you. What I've taken is AutoSAR, CAN for Linux, CAN Pi, the Cms Can Driver, and Socket CAN. So why I've taken those? First of all, we had experience with that. That makes things easier. Second thing is, the documentation for all of these things are freely available. And the third point is that for the last 4, these CAN for Linux, CAN Pi, Cms, and Socket CAN, the sources are also freely available because these are open source projects. So that it makes it a little bit more easier to see how are the differences. And all of them are already claiming, yes, we support CANFD. So first of all, let's have a look to AutoSAR. AUTOSAR is available since 2003, as far as I know, and it was founded by Siemens VDO, Volkswagen, BMW, Bosch, and some other companies, and with the idea to have a common integrated structure for ECUs in automotive area. The current version of AUTOSAR is the version 4.3, and this is one of these 5 selected APIs that has a commercial license, which means you have to be a member of AUTOSAR and pay your annual fees in order to support that and get more information. For CAN, and only for CAN, you have about 7 documents, and you have more than 100 functions that you have to cope with. That's the bad news. The good news is you typically have a graphical user interface where you just simply click around, which does everything for you, and you set up your application, and this somehow works, and you're done. But this AUTOSAR is typically not designed for PC interfaces. And so again, my intention is I want to have one thing for all. I want to have the situation that, for example, if I write code and I just want to say printf, or I would like to have a trigonometric function, I include a certain file, and only that. And then I exactly know if I want to call a cosine function, I just call in CRS, and that's done, and I'm done. And that is the idea that I would like to share. The next thing is CAN for Linux. The daddy of CAN for Linux is sitting there. And it started in the year 1995, as far as I remember. This CAN for Linux is under GPL version 2. It has an HTML documentation and simple 5 functions, because it typically runs only under Linux, and there you have an open and close and read and write and an I/O control, and you're done. It supports already a timestamp with a resolution of 1 microsecond. The next thing is CanPy, which is under version 3. It is available under LGPL version 3, which gives you the possibility to also include this in commercial things and derivate your code. It has a PDF and HTML documentation, 21 functions. It's also typically focused on microcontrollers, and it's just starting to support PC interfaces. The next thing is the Cms Can Driver, which is available under version 2.04. For years now, they haven't changed that. Available under Apache 2.0 license, also HTML documentation, roughly about 17 functions, but only focused on ARM microcontrollers because it's part of the CMSIS model, and it's within the Kyle MDK available. So, last but not least, we have SocketCAN, which is, from my point of view, a child which has some problems, because the version actually is unknown. It's GPL version 2. You find some documentation. It's a text file in the Linux kernel headers, so it really helps if you are a nerd and addicted to Linux, then you find something that you might know about this. It has 6 functions, and the actual version, they made it that way that they said, okay, we have CanFD, we set up a new structure for that, and so now you have to deal with different structures. You have to be root to set up the bitrate, and well, from my point of view and my experience, this API is sometimes really a nightmare. Especially, it consumes a lot of CPU time when you're running it on embedded systems. And this is called because of the design running in the network driver. Okay, what we have done now is we compared with this criteria I gave to you, we compared the different things, the different models. And let's say we gave some points or we gave some remarks. Like you can see here, there's a plus, there's a minus, or there's an O. Plus means, yes, this is supported. Minus means this is not supported or not applicable. And the 0 means this is partly available. But as I said, these are my criteria and my personal view of these APIs. And maybe you come to another solution. So when we glance through it, you will see the different criteria like fin state automation. Is it generally supported? Does it have a self-test? Does it support receive only low power? Does it have message buffers, acceptance filtering, and so on? I won't go together with you through all these tables there in the paper. So at this point, you may think, okay, who's the winner? But I'm not here like with the European Song Contest, where I say, okay, and here are the results of the jury from Germany. Autosar, 10 points. Autosar, 10 points. No, I won't make this. That is something where you should sit down and see if the criteria fits for you and come to your own solution. So now the question is, what is the conclusion? Well, for this conclusion, I said it's maybe a good idea to have a dream. To have a dream like Dr. Martin Luther King in 1964. And I took the speech that he gave in Washington in 1964, and I modified some of the sentences he made in this famous speech. I have a dream. I have a dream that one day all manufacturers of car hardware will be able to sit down together at the table of brotherhood. I have a dream that one day this CAN community will rise up and live out the true meaning of its creed. We hold these truths to be self-evident, that all CAN APIs are created equal. I have a dream today. Thank you.
Are you a dreamer? All companies worldwide, that's a challenge. So,
yes, okay. That's the reason why I'm here.
Thanks for your presentation. Do you have any question to Mr. Koppe?
I was involved in the CR document 601-2, and we had discussions about what to write there, and you also referenced many points, but the point regarding the number of message buffers and the type of message buffers and receive and transmit buffers, we couldn't agree because we didn't get enough user input, and you requested here long FIFOs, priority queues, and so on. Where does your wish come from? Are these the projects you work on, or?
Definitely yes. So you must see, of course, I'm focused on CANopen, and CANopen and J1939. So my experience is coming from these fields. And if you're asking me how many buffers would you like, I would say from CANopen, 32. This is something where I would say, yes, I'm happy with that. But I know there are IPs on the market which offer more than these number of message buffers, and there are IPs on the market which have no number of message buffers. But the point is, at this point, I'm not talking about the IP. I'm talking about the API, which is one level higher. So actually, if the board manufacturer gives me an API which emulates a buffer, I'm happy with that.
Other questions from your side?
I have also the same dream, but in addition, there should be similar API in all commonly supported operating systems. Now in the Windows side you have something, in the real operating systems based on Unix variants you have something, and then in some other operating systems you have just another. That should be also harmonized so that we have only single API, independent of the hardware, independent of operating system, and independent of programming language.
I totally agree on that.
Any additional question from your side?
So what do you think went wrong with AutoSAR? I see that there are more than 100 functions in that API, while all the others you have shown in your comparison have less than 20.
Well, I think that is caused to maybe the complexity of AutoSAR. I really don't know if we really need all these 100 functions. I mean, actually, I'm not so deeply involved in the development of AutoSAR. Maybe there are reasons for that I don't know. I just glanced through all those documents and said, okay, these functions are there, how many are these? And I just counted them. I mean, in the end of the days, you will possibly not use all these 100 functions.
Any additional question? Okay, then thank you very much again.